All right, so here's part 2. We're at question 14. You're given the graph of the derivative, and it says, does f have a local minimum at c? Well, at c, it goes from a positive to a negative, so that's a maximum. At a, it goes from a negative to a positive, so at a, it's a minimum. And then here, where it turns, when the derivative graph turns, that's a point of inflection. So a is wrong. F has a maximum at B. That's wrong. The graph has a point of inflection at A and F at A. Wrong. The graph has a point of inflection at B and F at B. That one is correct. The graph of F is concave up on the open interval from C to D. Now, from C to D, it is decreasing, so it's actually concave down. So the only one that would match would be D for question number 14. The graph has a point of inflection at B and F at B. Number 15. In number 15, you have a table of values. So we have the function, the derivative, and the second derivative. And the question is, let f be a function that is twice differentiable. If f at x equals f at negative x, what are the coordinates of the points of inflection of the graph of f from negative 2 to positive 2? So step number 1, I want to organize the information a little bit in question number 15. So if I want to understand where the points of inflection are, that's where it changes from negative to positive. And then you have all these different options here that you have to look at to see which one would match. Make sure I'm doing it right. So from negative 2, okay, I understand. It took me a second. So you're given from 0 to 2, and that's all you're given. And it says that f at x equals f at negative x. So whatever it is in this direction to positive 2, it would be exactly the same here to negative 2. So this is f at negative x, this is f at positive x. They're equal to each other. So from 0, and I'm only going to look at the second derivative because it's the point of inflection. So from 0 to 1, it's negative and then positive. So I know right here is a point of inflection. And then this reflects, like this f. So from 0 to 1, it's negative. So 0 to negative 1, it's the same sign. From 1 to 2, it's positive. So from negative 1 to negative 2, it's positive. So that, and then where's our other point of inflection where the sign changes? So there are 2 points of inflection, at negative 1 and at positive 1. Number 16. You're given a table of values. So I'm just going to plot them so that one is at 3 and negative 2. Sorry, negative 2 and 3. Let's do that first. At 1 and 0. At 4 and 3. Sorry, at 3 and 4. Should I read it right? This should be 0 and 1. I like totally do that. So this is 0, 1. This is 3, 4. Uh, 5, 7. And then 6, 5. So I'm going to connect them together, and then I'm going to see what the answer could be. So it says, which one could be the correct answer? And so I want you to notice this changes from concave up to concave down. The graph is concave up. The F is increasing. It has no critical points. It has at least 2 relative extrema. So it has these right here. So has at least 2 relative extrema. That's a good answer. And there's my answer. Number 17. This covers a few pages here. So you're given the graph of a function. Which of the following could be the graph of the derivative? So for me to understand this, I'm looking at increasing and decreasing first. So I'm just going to draw and realize that this graph is decreasing, then increasing, and then decreasing. So it's below, for the derivative graph, it's below, then above, and then below. That's what I'm looking for. Below, and then above, and then below. So A can't be right. So below, above, below. That one looks really good. And if I look at the other options, this one's all below. This one is below, above, below, above. This one is below, above, and then below. But it has that right here. It has that point of inflection that there. So the one that would match it, and there's a point of inflection right here, there needs to be a point of inflection as well. So this is below, and then above, and then below, and then at 0, do we have a concavity change? So we can go back to the graph. And so notice it is concave up, and then at 0, it goes to concave down. So there is a concavity change. So the answer is B is the one that would match it. So it's below, above, below, and at 0, there's a turning point on the derivative, which makes a point of inflection. Next one. All right, you're given the graph of the derivative in number 18. And the graph of the derivative is undefined at x equals 0. Now that could be a sharp turn, or that could be an asymptote that way. What else do I know? Is right here it is above, which means it is increasing. It is still above, and then it's below. So if I drew a number line here, all the way up to 0, it's increasing. 0 to 1 is increasing, and then after 1 is negative, and it's undefined at 0, which could be an asymptote or it could be like a sharp corner. So then which function could match that? Increasing, continues to increase, and then decreases. So when I look at A, I see it's increasing. I see at 0 it's undefined. It continues to increase at 1, and then after 1 it decreases. So the correct answer for number 18, what question are we got? Yes, number 18 is A. So if you looked at each option, and the reason it matches is because it increases, and then it's undefined, and then it increases to 1, and then it decreases. Number 19. All right. In number 19, the function f is twice differentiable and you have selected values. And then it says, which of the following could be the graph of the second derivative of f, if that's the function? And so if I try to graph f at x to begin with, so 1, 1, 2, 3, 3, 4, 4, 1, 5, and negative 2, and then 6 and 1. So it's concave up to begin with, and then it's concave down, and then it's concave up all the way through. So that's what I'm looking at. So I'm looking at above, below, and then above. So that's going to match with D. Above, below, and above. Number 20. In number 20, you have three graphs. One is the function, one is the derivative, and one is the second derivative. And then when you look at it, you need to think of increasing and decreasing, and you need to think of concavity. So if you look at number 3, number 3 is first, it's concave up. And I'm going to write it like that. And then after you look at numbers, so you look at each one like this. So at first it's concave up, and then it's concave down. And then the last part is concave up again. So if 3 is the function, which one is above, and then below, and then above again that matches it? So it's first of all above for concave up, and then when it's concave down, it's below, and then when it changes to concave up again, it's above again. So number 1 would match the second derivative. And then when I'm looking at the first derivative, this is decreasing to 0, and then increasing after it. So if I look at 2, notice it's below, and then at 0, it's above. So 3 is the function. The first derivative, which shows increasing and decreasing, that it's decreasing and then increasing. And then the second derivative, concavity, concave up, concave down, and then concave up. So that's the correct order. So for number 20, that matches with the function's f, the derivative's 2, and the second derivative is 1. That matches with e. Number 21. 21 is a calculator question. From negative 1.5 to 1.5, let f be that function. Which of the following are intervals where the graph is concave down? So let's take out our calculator. So if you're given the first derivative, step 1 is to take the second derivative. So that means the next derivative. So you're given the derivative, so you just take the derivative again. So the derivative of the derivative is the second derivative. And I'm going to solve an equation. So we're going to go algebra and then solve this. And what you're solving is the derivative of e to the x to the fourth, subtract 2x squared, plus 1. It's all in the exponent, and then subtract 2. So e to all of that, and then subtract 2. So that's the derivative. We're going to make it equal to 0, comma x. And so I get the answer -1, 0, or +1. Now we're looking from -1.5 to +1 so they're all in the correct interval. So I'm going to draw a line from -1.5 to +1.5. And then the critical numbers are -1, 0, and +1. So when you make it equal to 0, that's the answers. And then we want to know, where is it concave down in that interval? So we need to type it in again, and then we're just going to plug in numbers and see where it's negative. So I'm going to type in e, again, x to the fourth, subtract 2x squared, plus, oops, it needs to go up there. Plus 1, and then move the cursor down, subtract 2. And then we're going to evaluate it. Oh, we need to evaluate the derivative. Ha. There we go. Evaluate the derivative of e to the x to the fourth, subtract 2x squared, plus 1, move the cursor, subtract 2, and we are going to evaluate that at different spots. So we'll first evaluate it at -1.25. And the answer is, what? Ha! I get it. There we go. So at -1.25, the answer is negative. We're just going to go back and forth. Once you have it typed in, it'll be simple. So that's negative. Now plug in a number between -1 and 0. So we already did the silly work here of typing it all in. So we're just going to type it again. And now it's going to be -0.5. That's a positive value. Do the work again, now positive 0.5. So every interval, plug in a number that's in the interval. That's a negative value. And then one more time, plug in a number between 1 and 1.5, like 1.25. And it's positive. All right. So now that we have that, where is it concave down? So it's concave down from 1.5, -1.5 to -1, and from 0 to 1. So the answer to that is D. 22. In 22, the graph of the second derivative shown above, what are the intervals in which the graph of the function is concave down? Oh, I like the easy ones. So concave down for the second derivative just means, where is it below? Where is it negative? This is concave down. This is concave down. So up to -1 and 1 to 3. So -2 to -1, 1 to 3. And that's concave down. And why is it concave down? Because the second derivative is negative in those intervals. Number 23. Another calculator question. Let f be the function given by that. What is the least value of x at which the graph of f changes concavity? So I need to find the second derivative to begin with. And where does it change concavity? And we're looking for it when it's equal to 0. And the answers here are 0.56 up to 2.44. So honestly, I'm just going to look from 0 to 3. Because all my answers are between 0 and 3. A ln can't be 0, so we'll make it 0.1 to 3. Because if ln is 0, it would be undefined. So pick a number, not quite 0, all the way up to 3, and we're going to do this with our calculator. So to find the second derivative, press the button beside the 9. And then go to the second derivative button, right there. And then what do we want the second derivative for? And we're solving something, so let's do that. SOLVE, or you can find it. So you can actually just type it in too. So there it is. So we're solving this. It's the second derivative. We're going to use the variable x. It's cosine 2x. And plus ln 3x. Double check, did I type it in right? Cosine 2x plus ln 3x. Beautiful. We want to make it equal to 0. We want to go comma x to solve it. And then I needed a restriction because it's trigonometric. It'd be good to have a restriction. So we're going to restrict it from 0.1 So from 0.1 to 3. So I get the answer 0.93 and the answer 2.33. Well, the only answer that's actually there is 0.93. None of the other answers are there. There's no option of it not to be that, so I don't even want to. If I wanted to test it, I could, but it's the only possibility is 0.93. So when you did that, that's an answer. The other answer is 2.33, but that's not even an answer on here. And you could test around 0.993 with the second derivative and make sure that the concavity change is there. All right, number 24. Let f be the function given by that f at x, x cubed subtract 3x squared subtract 6x squared. The graph of f is concave up when? Oh, I like these simple questions. So I need to know the first derivative. That is 3x squared minus 12x. I need to know the second derivative. That's what gives me concavity. So the second derivative is 6x, subtract 12, make it equal to 0. If I solve this, x is equal to 2. Draw a number line for the second derivative. Plug in a number smaller than 2, like 1, and the answer is negative. A number bigger than 2, the answer is positive. So the question is, the graph of f at x is concave up when? And the answer is when it's bigger than 2. So the answer is A. (25) If the second derivative equals x times x plus 2 squared, then the graph of f is concave up 4. So you're already given the second derivative. So all you need to do is make it equal to 0 and solve it. So the two answers there would be 0, and the other answer would be -2. Those are the two answers that would make it 0. If I drew a number line for 0 and -2, if I plug in a number smaller than -2, I would get a negative times a positive. If I plug in a number between -2 and 0, like -1, it's negative times a positive. It stays negative. And then if I plug in a number bigger than 0, that one's positive. So the only time the concavity changes is right here, between negative at 0, where it changes from negative to positive. Oh, where is it concave up? It's when it's bigger than 0. So the answer is B. That's when it's concave up. 26. So the function f has the property f at x, the derivative, and the second derivative are negative for all real values. Which one could be it? So if they're all negative, that means the function is below, decreasing, and concave down. Below, only decreasing. So why is this one wrong? Because it increases and decreases. This one, it needs to be below, it needs to be decreasing, and it needs to be concave down throughout. That is the correct answer. So the correct answer is B. It's negative for everything. The function is negative, it's decreasing, and it's concave down. B is the one that matches. 27. In number 27, if g is the function given by that, there it is, on which of the intervals is g decreasing? So I need to take the derivative. So that's 3 times a third is just 1. So it's 1x squared. 3 times 3 halves is 3, and it's 3x. And then minus 70. Can you factor this? Yes. That would be 10 and 7. I can do that. And then the two solutions would be -10 and +7. So we're going to draw a number line for that. So for -10 and 7, so if I plug in a number smaller than -10, you get a negative times a negative, which is positive. Plug in a number like 0, and you get a positive times a negative, which is negative. And then plug in a number bigger than 7, and you get a positive answer. So the question is, where is it decreasing? And the answer is between -10 and 7. So the answer to that is D. All right, there's part 2. I'm going to do another video starting with number 28. All right, Mr. G Math over and out. Till next time. And I'm proud of you for working hard with me. There it is.